Good morning! Today we will learn how to solve geometry problems involving quadratic equations. So how do we solve geometry problems involving quadratic equations? First, let us recall the formulas in finding the area and perimeter of a square and a rectangle. So remember that in finding the area of a square, it is simply equal to the square of a side. For its perimeter, the perimeter of a square is equal to 4 times the measure of a side. While in that of a rectangle, the area is equal to length times the width. While the perimeter of a rectangle is equal to twice the length plus twice the width. Let's have some examples. So for number 1, find the area and perimeter of a square with a side which measures 5 centimeters. So for the area of the square, it is equal to the square of a side. Therefore, we have 5 centimeters raised to the second power, and that is equal to 25 square centimeters. For the perimeter of the square, the formula is 4 times the measure of a side, and that is 4 times 5 centimeters. Therefore, the perimeter of the given square is equal to 20 centimeters. Let's have number 2. For number 2, we have a rectangle whose length measures 9 centimeters and whose width measures 4 centimeters. Find the area. The area of a rectangle is equal to length times width. Therefore, we have 9 centimeters times 4 centimeters. So the area of the given rectangle is 9 times 4, 36 square centimeters. How about the perimeter? The perimeter of a rectangle is equal to twice the length plus twice the width. So we have 2 times 9 centimeters plus 2 times 4 centimeters. And that is equal to 18 centimeters plus 8 centimeters is equal to 26 centimeters. Number 3. A square with a side that measures 11 millimeters. Again, the area of a square is equal to s squared. So we have 11 millimeters raised to the second power. 11 to the second power is 121. So the area of the given square is 121 square millimeters. Okay, for the perimeter, we have 4 times the measure of a side, or 4 times 11 millimeters. So the perimeter of the given square is 44 millimeters. Number 4, a rectangle with a length of 25 meters and a width of 10 meters. The area is length times width. So that is 25 meters times 10 meters. 25 times 10 is 250. So we have 250 square meters for its area. For its perimeter, we have twice the length plus twice the width. Twice of 25 meters plus twice of 10 meters. So we have 50 plus 20 meters, and that is equal to 70 meters. Number 5, a rectangle with a length of 8 centimeters and a width of 5 centimeters. The area is length times width, so 8 centimeters times 5 centimeters. Therefore, the area of the given rectangle is 40 square centimeters. And then for the perimeter, twice the length plus twice the width. So we have twice of 8 centimeters plus twice of 5 centimeters. That is 16 centimeters plus 10 centimeters, and that is equal to 26 centimeters. Okay, let's now have some examples of geometry problems involving quadratic equations. So let me read the first example. The length of a rectangle is 3 centimeters more than its width. The area of the rectangle is 108 square centimeters. Find its dimension. So for our first step, we will assign a variable that will represent the width and the length. So let's say, let x be the width. So if x is the width, it says in the problem that the length is 3 centimeters more than the width. So how do we represent 3 centimeters more than the width? So if the width is x, therefore the length will be represented by x plus 3. We can also illustrate the given problem. So let's say this is the given rectangle. This is the width represented by x, and the length is represented by x plus 3. It says in the problem that the area of the given rectangle is 108 square centimeters. We know that the formula for the area of a rectangle is length times width. So we have the length, which is x plus 3 times the width, which is equal to x, is equal to the area. And the area is equal to 108 square centimeters. So we can represent our equation this way. Using distributive property, we have x squared plus 3x is equal to 108. By addition property of equality, we have x squared plus 3x plus negative 108 is equal to 108 plus negative 108. So the equation now becomes x squared plus 3x minus 108. This is now our quadratic equation, which can be solved using the method of our choice. So let's say we choose factoring in order to solve the given equation. Okay, so we have x and x. Now what are the factors of negative 108, which will give us positive 3 when added or subtracted? That would be positive 12 and negative 9. Because positive 12 times negative 9 is negative 108. And positive 12 minus 9 is positive 3. Apply zero product property. So we have x plus 12 is equal to 0 and x minus 9 is equal to 0. Solve for x, we have negative 12 and positive 9. So as you can see, x sub 1 is a negative number. Since there is no negative dimension, so we will disregard negative 12. Again, there is no negative dimension. So we will only consider 9 as the value of x. So if the width is represented by x and x is equal to 9, therefore the length, which is represented by x plus 3, is equal to 9 plus 3, and that is equal to 12. Therefore, we say that the dimensions the dimensions of the rectangle are 12 centimeters and 9 centimeters. Let's have another example. The perimeter of a rectangular table is 46 centimeters. Its area is 132 square centimeters. What are the dimensions of the table? So we know that the product of the length and the width of the rectangular garden represents its area. And that is equal to 132. We also know that twice the sum of the length and the width of the rectangular garden gives the perimeter. That is twice the length plus twice the width. And that is equal to 46. Now, if we divide this entire equation by 2, it will give us length plus width is equal to 23. This now represent the sum and the product of the roots of a quadratic equation. So this represents the product of roots. This represents the sum of roots. We know that if the sum and the product of the roots of a quadratic equation are given, we can identify or determine the quadratic equation, which is given by the formula x squared minus the sum of roots x plus the product of roots is equal to 0. So if we substitute these values in the given formula, we have x squared minus the sum of the roots is 23 plus the product of the roots, which is 132. Let us remove the grouping symbol. So we have x squared minus 23x plus 132 is equal to 0. So we can now solve it using any method. Let's use factoring. So what are the factors of 132 that will give us negative 23 when added or subtracted? That would be negative 12 and negative 11. Because negative 12 times negative 11 is equal to 132, and negative 12 plus negative 11 is negative 23. Let us solve for x, or let us first apply the zero product property. X minus 12 is equal to 0, x minus 11 is equal to 0. Solve for x, we have x sub 1 is equal to 12, and x sub 2 is equal to 11. With the obtained roots of the quadratic equation, the length and the width are 12 centimeters and 11 centimeters respectively. So the dimensions we have: length is 12 centimeters and width is equal to 11 centimeters. Let's have another one. A rectangular swimming pool measuring 6 meters by 10 meters is surrounded by a complete path of uniform width. If the area of the path is 192 square meters, find the width of the path. So first, let us illustrate the given problem. So according to the problem, there is a rectangular swimming pool which measures 10 meters by 6 meters. According to the problem, it is surrounded by a complete path of uniform width, which means that the distances are the same. So let us represent the width of the path as x. Let x be the width of the path. According to the problem, the area of the path is 192 square meters. Now, how can we represent the length and the width of the entire figure? So this can be represented as 6 plus twice of x. Now, for the length, we have 10 plus twice of x. So we know that the total area of the entire figure is equal to the area of the pool plus the area of the path. To get the area of the pool, we multiply 10 meters by 6 meters plus the area of the path, which is already given in the problem, 192 square meters. So we have 60 plus 192, and that is equal to 252. This is now the total area of the given figure. The total area of the figure can be represented by the product of 10 plus 2x and 6 plus 2x, and that is equal to 252. By FOIL method, we have 60 plus 20x plus 12x plus 4x squared is equal to 252. Combining like terms, we have 60 plus 32x plus 4x squared is equal to 252. Applying zero product property, we will have 60 plus 32x plus 4x squared minus 252. So we now have 4x squared plus 32x. What is 60 minus 252? That is equal to 192 is equal to 0. So as you can see, 4x squared plus 32x minus 192 is equal to 0 can still be reduced. Divide the entire equation by 4. So we're going to have x squared plus 8x minus 48 is equal to 0. Let us solve by factoring. So we have x plus minus, what are the factors of negative 48? That will give us positive 8 when added or subtracted. That would be positive 12 and negative 4. zero product property, we have x plus 12 is equal to 0, x minus 4 is equal to 0. X sub 1 is negative 12, x sub 2 is positive 4. So what are we going to do with negative 12? Since there is no negative dimension, so we will disregard negative 12. Again, since there is no negative dimension. So we have x is equal to 4. So which means that the width of the path is 4 meters. So that is how we solve geometry problems involving quadratic equations. Thank you very much.